A single Bitcoin transaction consumes enough electricity to power an average American home for over a month. As the grid strains, mining facilities are being blamed for pushing local climates to the brink. But in a remote corner of West Texas, engineers are flipping the script by turning wasted flare gas into a catalyst for a hidden green energy revolution. This isn't just about mining, it is about the most radical power shift the grid has ever seen. Into the details. The process of mining Bitcoin is often described as a digital gold rush. But unlike the prospectors of the 19th century who needed picks and shovels, modern miners need massive warehouses filled with thousands of specialized computers. These machines, known as application specific integrated circuits, or ASIC miners, perform trillions of complex calculations every single second to verify transactions on the blockchain. This process is called proof of work, and it is designed to be intentionally difficult and energy intensive to ensure the security and decentralization of the network. You might have seen the viral images of shipping containers packed with these machines, humming with a sound like a swarm of angry hornets, all while drawing massive amounts of electricity from the grid. In 2024, the total electricity consumption of the Bitcoin network was estimated to be around 150 terawatt hours per year. To put that number into perspective, that is roughly equivalent to the annual electricity consumption of countries like Argentina or Sweden. That is a staggering amount of power. If you look at the environmental footprint, the primary concern is the carbon intensity of the energy sources powering those rigs. If a mining operation is plugged into a grid heavily reliant on coal or natural gas, the carbon emissions can be significant. A report by the Cambridge Center for Alternative Finance found that the network's annual carbon footprint has historically tracked with the carbon intensity of the energy mix it draws from. But this is where the conversation takes a turn. Think about the incentives. Bitcoin miners are profit-driven, and electricity is the single largest operating expense for any mining facility. Because of this, miners are constantly hunting for the cheapest electricity on the planet. And what is consistently the cheapest form of electricity today? Renewable energy like wind, solar, and hydropower. This leads us to our first actionable insight. Miners are increasingly acting as a bridge for renewable energy projects that would otherwise be financially unviable. Consider the case of the remote wind farm in West Texas. For years, this project struggled because it produced far more energy than the local population could consume, and there was no way to transport that excess power to distant cities. The developers were essentially throwing money away. Then, a Bitcoin mining company arrived and set up shop right at the base of the wind turbines. They became a flexible, interruptible consumer for that excess energy, providing the wind farm with a guaranteed revenue stream. That revenue allowed the developer to build even more turbines, expanding the capacity of the entire regional grid. If you are enjoying this deep dive into the intersection of technology and sustainability, hit subscribe. I drop videos like this every week to help you understand the forces shaping our world. That leads us to the second, more nuanced layer of the impact: demand response. In many power grids, the greatest challenge is balancing supply and demand in real time. When energy production spikes, say on a very windy afternoon, but demand is low, the grid can become unstable, and operators might even have to curtail or shut off clean energy sources. Bitcoin miners provide a unique solution here because their operations are entirely location agnostic and highly interruptible. They can instantly power down their rigs when the grid faces peak demand from households and businesses. This functionality, known as demand response, creates a symbiotic relationship between the miners and grid operators. During the winter freeze of 2021 in Texas, for example, many mining operations voluntarily shut down their machines for days, returning hundreds of megawatts of power back to the grid to keep homes warm. This shows that when designed correctly, Bitcoin mining isn't just an energy hog. It can be an anchor tenant for renewable energy expansion. It stabilizes grids and makes green energy projects more profitable. Now for the one I've been saving for you. The third, and perhaps most controversial application, is the utilization of methane gas. Methane is a potent greenhouse gas, far more damaging to the atmosphere than carbon dioxide over a 20-year period. Much of it is released as a byproduct of oil drilling, a process called flaring, where the gas is simply burned off at the wellhead because it is too expensive to transport or store. It is essentially wasted, leaking into the atmosphere or being turned into CO2 through inefficient combustion. Here is where it gets interesting. New portable mining rigs are being deployed directly to these oil wells. Instead of just burning the methane, The gas is diverted into generators that power the ASIC machines. By consuming the methane to generate electricity, these rigs are performing a process called mitigation. They turn a waste byproduct into productive compute power. In some cases, this process has been shown to reduce methane emissions by over 90% at the wellhead. Think about that. By mining Bitcoin, companies are doing something that traditional environmental regulations have struggled to enforce for decades. They are creating a financial incentive to stop the pollution that everyone else has just been burning away for free. Let that sink in for a moment. The narrative around Bitcoin and the environment is changing from one of pure consumption to one of potential energy optimization. While critics are right to point out the high energy costs and the dangers of fossil fuel reliance, the industry is increasingly moving toward renewable integration and emission mitigation. It is a complex, evolving picture, and the reality is far more balanced than the simple headlines suggest. So, there you go. 3 ways to understand the environmental impact of Bitcoin mining, from the raw electricity usage to the potential for stabilizing green grids and reducing methane leaks. The last point alone reveals a future where digital finance and environmental stewardship might not be as contradictory as they first appear. If you got value from this, share it with someone who is asking the hard questions about our digital future, and subscribe so you don't miss the next deep dive. Next week, we are looking at how advanced satellite technology is monitoring the health of the entire planet's forests in real time. Stick around for that one.